Hello everyone, this is another video in which I'm going to explain two more problems based on the prefix sum and hashing pattern. And in this, just a small change means I'm also introducing one another concept, that is a modulo concept. So the core pattern is going to be prefix sum hashing and the modulo pattern. Now in this particular video, I'm going to explain two problems. One problem is to count the number of subarrays whose sum is divisible by k, and another problem is to check if any of the array is present or not, whose sum is multiple of k. Okay, so these are the two different problems. Okay, so in this particular video, I'm going to explain one simple core idea which is going to help us in solving both the different problems, which involves the key. So by the end of this video, we won't be memorizing anything. We will be understanding the exact pattern, that how we have to solve a particular problem, which having this particular scenario, like where the subarray is there and we have to find for the sum of with the divisibility or multiples. Okay. Okay, so this is a simple example which I have taken, and in this the simple case is that I am having a particular number which is when divided by 6, it is going to give us the remainder 5. Now we have to get all those numbers which when divided by 6 they will be leaving the remainder 5. So how we can find it? Just a small trick, we can say that whenever we are having such kind of case that we are having a number when divided by 6 gives a remainder 5. Okay, so we are having 5 here, this is as a first number, and now when we add 6 into this, it will give us second number, that is 11. Now add 6 to this 11, it will give us 17. Add 6 to this 20, this 17, it will give us 23, and then another number is 29, and so on. So we will get these numbers in this way, whenever like start with the 5 and then add 6 every time to get the newer number. So this is how we are getting a list of numbers. Now what does this mean? So when we take now what I'm trying to say here is that whenever we are having this kind of list of numbers which are when divided by a particular number, they leaves the same remainder. So now if you take any of the two numbers among this list, and when you take the difference of it, like either even if you take 5 and 11, when you take the difference it will give 6. So this is 6 is something which is divisible by 6, means this particular k value. Okay, and then you can take 11, 17. So when you take the difference it will be 6, again it is divisible by 6. 17, 23, when you take the difference it will give you a particular number which is divisible by 6. And not only the adjacent values, like 5 and 17, if you take the, you will get the difference 17 minus 5 as 11, as 12, and it is again divisible by 6. Then you can also take like 23 and 5, so the difference will be 18, and again it is divisible by 6. So just I want to say is that whatever the list of numbers you are having right now, which are when divided by 6 and leaving the remainder 5, means the same remainder. So what we can say is that these all the numbers are belonging to the same mod group. Same mod group means mod 6 group. So they belong to the mod 6 group, or we can say the same mod group. Now the simple observation we are making here, that all of these numbers when they are divided by 6 giving the same remainder, and whenever we take the difference of any of the two numbers out of this, that particular difference is going to be divisible by key. And this is something which is, we can say, a vice versa, like even either we can say that all of the numbers are here, and all are giving the same remainder. Therefore we can say that whenever the two numbers are taken of which are giving the same remainder, they the, the difference which they give, that particular difference is divisible by key. Or we can say in reverse way, that if we are having two numbers which are having the difference which is divisible by key, therefore those two numbers are having the same remainder. So this is something which I have written. Now this is we have just understood with the help of example. Let's just see here what is written. So the same thing is written here, that if the difference of two numbers is divisible by key, then both of the numbers leave the same remainder when divided by key. Just here we can see that these 5 and 11 are the two numbers. Here we are saying that it is means the difference is divisible by key. The 6 is divisible by key. 6 is divisible by 6. Then both of the numbers leave the same remainder when divided by key. So when 5 is divided by 6, it leaves the remainder 5. 11 divided by 6, it leaves the remainder 5. So this is the meaning. And now you can also say in the reverse way, like this is just a reverse, the second statement, that if both the numbers leave the same remainder but when divided by key, then the difference of the two numbers is divisible by key. So this is just a mathematical notation which I have written, means a double implication sign, that if this, then this can happen, and if this, then this can happen. Okay, this is just a mathematical notation I have written. Now now I am just mapping this particular situation with our problem, means with our logic, how we are going to solve the problem. So what will happen is, in the input array which we are having, means how we are going to solve the problem, basically the prefix sum and the hashing pattern only we are going to use. So what we already know, let's just discuss what we already know. So we already know that if a prefix sum is there at a current index and another prefix sum is also there in the past. Now if we take the difference of these two prefix sums, then whatever the sum comes, or we can say a difference comes, that is basically a subarray sum. Okay, it's just like that. Like this, if we are having this particular input array and I'm seeing that till here this is the prefix sum, means this is the current prefix sum I'm having, and in the past this was the prefix sum. If I take the difference of both, so this complete prefix sum minus this prefix sum, so it is going to give me this particular part, or I can say the sum of this subarray. So now how I can map this thing. See, here as this particular list we have seen that this is the particular numbers, the list of numbers, or we can say a group of numbers which belongs to the same mod group. Okay, so let's just consider that this 5 and this 17 are present in the input array. This is one prefix sum at a later index, or we can say at the current index, and this 5 was the prefix sum in the past. So now I can see that these both prefix sums, or these numbers in this case, are having the same remainder, because when they are divided by 6 they will be leaving the same remainder, and because the two numbers leave the same remainder, therefore they belongs to the same mod group, means a mod 6 group. And hence if I take the difference of both of these numbers, therefore that particular difference is going to be divisible by 6. This is we can say a mathematically proven way, and we have also already seen in this example. So just the same case is going to happen in the prefix sum approach as well. We will be having a particular input array, we will be having one prefix sum here, and let's say we are having one prefix sum here, we are having k equal to 6. Now when this particular prefix sum is divided by 6, we are going to have a particular remainder, and we will be then checking for that same remainder earlier. Okay, means if both of the numbers, if both of the prefix sums are having the same remainder, therefore I got the approach, I got the logic that okay, these two prefix sums are having the same remainder, therefore if I take the difference of both, that particular difference is going to be divisible by k. That's what it's all about, this logic. Now we have understood that how the logic is going to work in background, and we have also seen an example that we have a complete clarity that how this particular approach is working. Okay, now I have to just discuss a small thing, but yet it is a very important, that it might happen that the remainder can become negative, because see, there might be the case where the input array is also having the negative elements, and because of which the prefix sum at one point of time it might also become negative. So in programming languages, what happens is if we do such thing like this negative number and we take the mod with 5, then it will be giving -1 only, means in the programming languages. But we know that mathematically it is not correct. If we talk in mathematical terms, then the remainder can only be from 0 to k-1. Like if mod k we are performing, then remainder can only be from 0 to k-1. But in programming languages like in CPP or Java, like that, so the -1 can come as a remainder if such case happens. Okay, and it is not at all a correct way, and it will not be giving us the correct result. So if we see this -1 mod 5, it is going to give -1. 4 mod 5, it is going to give us the remainder 4. Now we know, like if we see in this case, let me just take an example again, that if I am having these numbers 5, 11, 17, 23, 29, I am saying that 5 is the number which is giving me the remainder 5 when divided by 6. Now if I go 6 steps back, so I will be getting -1 here, -1, and after that 5, then 11, then 7. Likewise, sorry, 17. So likewise, I will be having some of the numbers here. So I can see from here that if I take the difference of these two numbers also, 5 and -1, so 5 minus -1, that will be 6. Again, that is divisible by 6. So therefore, -1 should also give the remainder same as that the 5 is giving. But we can say in the programming languages, when we take the remainder of this -1, it will be what? -1 mod 6 is going to give me the remainder -1. And if I take the remainder of this 5, so 5 mod 6, it is going to give me the remainder 5. Okay, that is the difference. But we can see that all of these numbers, like from 5, 11, 17, 23, 29, these all when divided by 6 are giving the remainder 5. But when this -1 is getting divided by 6, it is giving the remainder -1. So that is what which is mathematically incorrect. And in order to correct it, what we can do is, in order to keep it in the correct range from 0 to k-1, we can just add plus k into that. means firstly we will be taking the prefix sum and the means the remainder of that prefix sum mod k, and if that value comes negative, we can just add plus k into that so that it comes in the correct range, in the valid range from 0 to k minus 1. Okay, so I have also mentioned this thing here as well, that whenever we are having such numbers like minus 1 is also giving the remainder minus 1 when divided by 5, and when 4 is divided by 5 it is also giving the same remainder. So if we see that minus 1 is and 4, these both belongs to the same modulo group. So therefore this minus 1 and 4, when they divided by 5, they give the same remainder. So if we are having any negative remainder, we can just use this, whatever the prefix we are getting, if it is a negative one, so we can just perform the mod of k, and because it is a negative, the remainder is coming negative, so we can just add plus k into that, so that it can come into its valid range, means from 0 to k minus 1. And after that we have to perform this mod k as well, because it might happen like if we are having this minus 1 and we perform the mod k, so minus 1 mod 5 will be giving us minus 1, and when adding plus k into that, means plus 5 into that, it is giving us 4, which is coming inside the valid range. And why we are performing the mod k again? So let's just consider in the case where the prefix sum is valid in itself, means there is no any negative number, it's a positive number in itself. Now we are only doing the mod k into it and then plus k, so it will be like, okay, so let's just consider that there is a positive number, it's a valid in itself. Okay, so now if you take that positive number, let's say I am having this particular range of values, like a particular number is there, and now when I'm performing, so it's like giving a value 4, and when I have performed this mod 5, okay, what are the numbers it can give? It can be like 4, and then can be like the 4, then plus 5 we can get 9, and means more values can come after this. And also here, before this, minus 1 can also come, as we have already seen. Okay, so this minus 1 can also be there, as we have already seen that if we take the difference of it, it is going to give a number which is 5 divisible by 5. Now among this, if the negative number is there, a negative prefix sum comes, then in that case it is correct that okay, minus 1 mod 5, it is giving us the remainder minus 1, and in order to take it back to the range, we are doing plus k. But what if the positive number comes? Let's say 5, let's say 9 is coming, that is a valid prefix sum in itself. Now if you take 9 mod k, means 9 mod 5, it is going to give the remainder 4, and then adding plus 5 in that, it is becoming 9. Now if you are not performing the mod k, it is going out of the value of k, out of the range. Okay, because k value is 5, and this particular value is going beyond 5, that is 9. So we will have to perform mod k. What will happen, that if any positive prefix sum comes, a valid prefix sum comes, then after taking the remainder, adding plus k to it, it will be, even if it goes out of range, after performing the modulus operation with k, it will come back to its original range, that is 0 to k minus 1. So this is the meaning of this particular condition. So we have to keep in mind whenever any, like for the negative remainders, and for the positive remainders it will also work. If the remainder is already positive, nothing we have to change, and if it's negatives, then we can just add k in order to push it back to the valid group. And this is a simple example which we have already understood, that if the prefix sum, let's say minus 1, and if k value is 5, the raw remainder which will come in case of this programming languages, it will be minus 1. But mathematically, because it is incorrect, so we will have to avoid such case. So the fixed remainder means, already we know that this particular is the list of numbers, they are going to give the same remainder, so that should belong to the same valid group. The fixed remainder can be this, whatever the mod value comes, prefix sum mod k, that minus 1, and then add plus 5 to it, so that it can go to the valid range. And in order to also keep in mind about the positive numbers, we have to also add this mod of 5, means mod of key at the end, that if also if it goes out of the value of key, okay, so that it can come in the correct range from 0 to k minus 1. So this is the fixed remainder case. Now why we have to normalize this modulo? So that it can be in the same remainder group. Okay. And also we will have to use the hash map. So whenever we will be storing the remainder inside the hash map, that hash map should have the same key. Because if we are using minus 1 itself only, then the hash map will have the different key, that will not be giving us the correct result. And also in order to get the correct subarray counting. So that's all for this. Now we have understood the logic, that how we have to use it, because now let's get directly into the problems and understand how we can solve them. So this is the first problem, subarray is divisible by key. Here the problem statement says is that we are given with an integer array nums of size n and an integer key, and a subarray is a contiguous part of the array, and our task is to count the number of subarrays whose sum is divisible by key, and then we have to return the count. Okay, so for this, firstly let me just take the simple example in order to make you understand. So this is the input array of 6 size and the value is 5. Now what the problem statement says is we are having this input array. We have to basically count all the number of subarrays whose sum is divisible by key, means whose sum is divisible by 5. Now how we will find it? Let's just discuss what we already know. We know that if we are at a particular current index after taking the running sum till now, at a particular index we are having a prefix sum and we got a particular prefix sum in the past. Okay, then how we will get the subarray? If we take the difference of both, then we will get the subarray. In this we have to count the number of subarrays. Now how we can get to know that this is a subarray which I want, means this is a subarray sum whose sum is divisible by 5. How we can get to know? Okay, so let's just go on top of the logic which we have already built, that if we are having a prefix sum at the current index and if we got a prefix sum in the past, now if both of these prefix sums are having the same remainder, then what does this mean? We have seen that if two numbers are having the same remainder, therefore if we take the difference of both, then that particular difference is going to be divisible by key. Now here the prefix sums are there. If both prefix sums are having the same remainder, then what does this mean? It means that those two prefix sums are belonging to the same mod group, and because they are belonging to the same mod group, means mod 5 in this case, then if we take the difference of both the prefix sums, that difference is going to be divisible by 5, means this divisible by key. So just look at here a simple reasoning. Let's do, if this is a current index, let's say I am having one prefix sum and this is a prefix sum, one prefix sum here. I have taken the remainders of both. Okay, it's like whenever I'm at a particular index and I got a prefix sum, I will be firstly taking its remainder, and now I will be checking in the map that have I got any remainder in the past, and if I got the same remainder in the past as well, therefore the index where I got that remainder, that was containing that prefix sum which has given this remainder. And now if I move that particular prefix sum out of this running prefix sum, I will get a subarray whose sum is divisible by key. And in this problem, because I have to count the number of subarrays, so I can check that how many number of times that same remainder appeared in the past. The number of times it appeared, for example, it appeared once. Therefore, let's say this is the J index. For example, just for example, this is the index G. And in the past, let's say here it got, this particular prefix sum got a remainder, okay, at this I index. So I can see that from this one index till this third index, I got a subarray whose sum is divisible by key. And let's say this was I1, and just and this particular index was I2, let's say, and it is also having the same remainder. Therefore, that remainder appeared two times in the past. So from this index onward, means from the second index, second to this third index, also having a particular subarray whose sum is divisible by 5. So this is how it works. We have also seen this particular approach, we can say, or thinking, that how we have to find for the number of subarrays. Means here I am getting, here I am seeing for the remainder. The number of times that remainder appeared in the past, that number of subarrays will be there, which will be ending at this current index. So this is all about the logic of it. Now let's just perform a dry run on this. So let me just take a map, and this particular map is going to be a frequency map, because I will have to have the frequencies of the remainders, that how many number of times that remainder came. So first of all, I will have to maintain a prefix sum. I will have to firstly maintain a prefix sum that will be initialized by 0, and I will also have to make a count, and that is also initialized by 0 as of now. Now what I have told in the previous problems, if we are having a prefix sum as 0 and it is a virtual prefix sum, now what we have to store inside this frequency map, we have to store the remainder along with their counts, that how many number of times they came. Initial step, whenever we are starting with taking the prefix sum, we just put it inside the frequency map in order to get the valid subarrays starting from the 0th index. This 0 will be inserted along with its count of 1. So this is one insertion we have done. Now let's start from 0th index. So at the 0th index, we are seeing that 4 is there. So when this 4 is added inside the prefix sum, okay, now 4 got updated inside the prefix. Now we will take the remainder, prefix sum divided by key. Now what is the remainder coming? Remainder is coming 4 mod 5. That is 4. Remainder is 4. Now we will be checking inside the map that how many number of times this remainder came. It doesn't came any of the times. So therefore, at the 0th index, we got a prefix sum 4, and after taking the remainder, means by performing the mod operation with 5, we got a remainder 4. So we will be just inserting this 4 inside this map because we have not got any of the remainder like this in order to have a count. So this particular remainder 4 came one time. Now I moves ahead and 5 comes here. Now prefix sum will be updated 4 plus 5, so that will become 9. And now again, when this prefix sum is performed, a prefix sum modulo key is performed. So 9 mod 5, it is going to give the remainder 4. Now again the remainder 4 is coming. So we will check inside the map that if 4 was encountered or not. 4 remainder came in the past or not. Yes, 4 remainder came and it came once. So let's just here. This 4 remainder came and we know that that particular 4 remainder came at this 0th index. Okay, and that was only once till now. So therefore, because that remainder came at this index, okay, so we can see here what was the prefix sum at this index. Prefix sum was 4. And what is the prefix sum here? The prefix sum is 9 at this particular index. Now if we take the difference of both, one prefix sum is 4 and another prefix sum is 9. Okay. And now we can see when we took the remainder, 4 mod 5, it gave the remainder 4. 9 mod 5, it gave the remainder 4. Therefore, if we take the difference of these two numbers, that particular difference is going to be a sum, you can say, which is divisible by 5. We can see that the difference is 5 and it is divisible by 5. So this is the meaning of it, what I have already explained. So this was one prefix sum at this 0th index, and another prefix sum was this at this first index. Both are having the same remainder. Now when the difference is taken, that particular value, that difference, or we can say a sum, divisible by 5, this divisible by key. So right now we are at this I index, and that particular remainder we got at this 0th index, we can see from the array, but from the map we can see that only was present one time. So because it was one time, this one will be added inside the count. That means the second parameter is getting inside the count, added inside the count. So therefore, count will be updated by 1, and we can get to know that okay, one subarray was there which is having the sum which is divisible by 5. We can just see that okay, this is the subarray, this we have marked. Okay, now we have incremented the count, that till now we have got a subarray with some which is divisible by key, divisible by 5. But now we will also have to insert this prefix sum remainder. Okay, so 9 and the remainder came, not 9 mod 5, the remainder is 4. 4 will also be inserted in this particular map, frequency map. But because the keys will be unique, so the second value will get updated. That will become 2 now. It means the 4 remainder which we have seen till now is 2 times. One is at the 0th index, and another one, the total prefix sum was 9. Therefore, another remainder 4 at one index. Now let's move this I ahead. So this is a 0. Now when the 0 is added inside this prefix sum, so it will still remain 9. And now again, if we take the remainder, so remainder will again be 4. How many number of times we have seen this remainder inside the map? That we have seen 2 times. From the map we can see 2 times, and in the array also we can see visually that once at 0th index we have seen the remainder 4, and once at 1 index we have seen the remainder 4. Okay. And now also, because the prefix sum is 9, so therefore again the remainder is coming 4. First of all, let's just add this second value, because the number of times that the remainder came in the past, that number of subarrays are going to form, which are giving the sum divisible by key. So again this count will be incremented. This time how many number of times? 2. Sorry, this 1 plus 2, that will become 3 now. So 3 subarrays till now. Let's just count, mark them. So one remainder we have seen at this 0 index, so therefore that one subarray will be from 1 to 2 index. 5 plus 0, that is the sum 5, which is divisible by 5. And another subarray is from this, at one index also we seen a remainder 4. So therefore at second index itself, this 2 only. sorry, at the second index, this 0 only. 0 is also divisible by 5, which is giving the remainder 0. So we have seen 3 subarrays till now. Okay, now let's move this I ahead, and this is minus 2 now. When this minus 2 is added inside the prefix sum, this prefix sum becomes 7. And when we perform the modulo operation, so 7 mod 5, it will give the remainder 2. Have we seen the remainder 2? No, 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 we have not seen. So we will just add this inside the map. That is 2 comma, how many number of times we have seen till now? Remainder 2, 1 time. Now I moves ahead, and when this minus 3 is added, so it becomes 4, and again we take the remainder, so the remainder will be 4 again, and we will see inside the map that how many number of times that remainder came. Okay, in the last, for the last one, means for the 0 subarray as well, we were getting the remainder 4, so we have not updated this with its count of number of times, so that was 3 in that case. Now this time when we see that okay, the same remainder came, so now this remainder will be checked inside the map, and it is now 3 times we have seen so far. One at 0th index, one was at 1 index, and another one was at 2 index. So therefore the 3 subarrays will be formed, which will be ending at this current index. Okay, so this count will be incremented by this 3, and it will now become 6. We have seen 6 subarrays so far. What are the subarrays? Let me just mark it. So one we have seen at the 0th index, so therefore from here to here, this is one subarray. Then what we have seen the remainder 4 at 1 index as well. So from here to here, the second index to this fourth index is also a subarray. Okay, so we can also see here minus 5 is the total sum, and when divided by, it is divisible by 5. And then another subarray is at second index also there was the subarray. Okay, and at the second index also we have seen the remainder 4. So from here to here we can also see that this was the subarray divisible by 5. Okay, 6 subarrays we have seen so far. Now this is again a remainder 4, so it will also be updated inside this map, and it will now become 4. 4 remainder we seen 4 times. One at 0th index, one at 1 index. The next time we have seen at second index, then at fourth index. Now I moves ahead, and this will become 5 now. Okay, so now the remainder is 0, because 5 mod 5 is 0. And have we seen this remainder inside the map? So yes, we have seen the remainder 0, and that was where we have not started taking the sum. So it means at this particular position. It means we can say from 0 to 5th index is the total subarray sum, which is divisible by 5. Let's just check it. 4 plus 5, 9. And see, this 5 gets cancelled, and 4 plus 5. This again, total sum is getting divisible by 5. So this is one complete subarray in itself, which is going to give the sum divisible by 5. The count will also be incremented for this, and now the count will become 7. Therefore, we have seen total 7 subarrays in this particular input array, which are giving the sum which is divisible by 5. So this is how we have to check and this particular approach. Okay, so now let's just get directly into the implementation part and implement this. So first of all, I will be just taking the unordered map here, ordered map, and I will be taking 2 parameters, one for the remainder and another one for its frequency count. Int comma int, and let me just name it as frequency map. And now I will be maintaining the 2 variables. One is the prefix sum variable initializing by 0, and another is the count variable, which I will be initializing as 0. And then I will be running a loop for auto val, and every value taken from the nums array. And after that, firstly I will be taking the prefix sum. So prefix sum equal to prefix sum plus this val, which I have taken from the nums array one by one. And once I have taken the prefix sum, then I will be firstly taking the remainder. Remainder equal to prefix sum mod key. Now after getting this remainder, first of all I will have to check for its status, like what is the status, like remainder is positive or it is negative. Okay, so I have already explained that if the remainder is negative, then we will have to take it to its valid position from 0 to k-1 range. So either I can explicitly write a case where I can just put a condition, a check, that if the remainder is negative, then I can just do in this way, that if this remainder is negative, this remainder is negative. Now I am just putting an explicit check here, and in that case, what I can do, I have already the remainder in my hand, prefix sum mod key, and if it is negative, then I can just add plus k to it. in order to take it to its valid range. But if I have to not add this situation or this condition explicitly, I can just add a simple line where I don't know the remainder is positive or negative. I can just write a simple line regardless of what the remainder is, like negative or positive. If the remainder comes negative, then in that case I can just take it to its correct position by doing plus k, so that it can be pushed back to uh, the valid range. And also after that explicitly putting a mod k, so that in case if the remainder is already valid, means a positive remainder, then in that case it might not go beyond k. Okay, so that we can write. But as of now I have just put the explicit case here, that if the remainder is 0, I'm just going to add plus k into that, so that it can go into the valid range. And after doing this, I have got a particular remainder which is a valid one. And now I am going to put a check, like I'm going to check inside the map, the frequency map, that the frequency dot find, if I have got the same remainder in the past, then I will be checking with this condition, frequency dot end. And if I am getting a particular remainder in the past, if I have got a remainder at this current index and I am checking for the same remainder in the past, if I have got it, the iterator will not be pointing at the end position, therefore this condition is going to true. And in that case I can just count the number of times that remainder came, so that will be frequency of that remainder. Okay, that is going to give me the second parameter or the second value which is going to be added inside this count, and that will now become the number of subarrays which are going to enter this current index. uh, After this, what I have to do, I need not to keep any check or something with the same remainder. Any number of times, whatever the number of remainders are coming, I will be just adding with its count. So frequency of this remainder, whatever the remainder comes, I will just do plus plus for that. So that will be just adding inside the frequency map along with their counts. And at the end, I have to just return the count. This is going to give me the number of subarrays which are whatever the sum their subarrays are having, which is divisible by k. And now let me just take a simple example which I have taken here, 450. The size is 6 and the array is 450 minus 2 minus 3 1 minus 2. And what all are the values I have to take in input? The k value I have to take, so that is 5. Means I want the subarrays with sum which is divisible by 5. Now let me just run this. So what the output is coming, there are 6 subarrays with sum divisible by 5. Okay, so we have got output that was 7. So what is missing in this case? I think I have not added a condition where frequency of 0. Okay, so for the 0 remainder that was came one time. Now let me just run it, so that that particular subarray can also come, which is starting from the 0th index. Okay, so there are 7 subarrays with sum divisible by 5. We have just missed this condition where the subarray was also starting from the 0th index. Okay, this entire subarray. Okay, so for this particular example, we have seen this is the output, this is the implementation. And now let's just check the time complexity and space complexity. For this particular code, we can see that a loop is running where it is taking every value from the nums array. And because we have used unordered map, so every operation like search operation, find this, insertion operation, they takes O of 1, like constant operation. So for that, for every value, because it is running for n value, so O of n is the time complexity. Okay, and for the space complexity, again, in the worst case scenario, that can be O of n. Okay, that is the space complexity. Okay, so now let's just see the another problem, that is subarray some multiple of k. Now this is just a small change in the wording and also some tweaks in the problem as well. So just the difference between the divisibility and multiple is that a divisibility, when we say a is divisible by b, the a kind of integer is coming, a remainder comes. When we say something is multiple of k, so we just write in the form of k into something like multiple. Okay, so for example, when we say 30 is divisible by 6, we say the remainder will come 0. And when we say 30 is a multiple of 6, so we can write 6 into 5 like that. Okay, so that is the difference, the small difference, but the logic is going to be the same. The one core idea which we have understood, that is going to be applied in the same way. So let's just read the problem statement. The problem is about subarray some multiple of k, and we are given with an integer array nums and an integer k. And again, this subarray is the contiguous part, and our task is to determine whether there exists a subarray of length at least 2 whose sum is a multiple of k. Okay, so just a small change, that we have to firstly check for the subarray if its length is 2 or more. and along with its sum should be multiple of key. Just a small change they have done for the length, and no, rest is the same thing. You have to apply the same logic here as well for the idea we have discussed. And then we have to return just true if any of the subarray exists, like even if one subarray exists, means we can check for its one first occurrence. And if we are not getting any of the subarray out of the input array, then we will just return false in that. Okay, so this is the example on which I have to perform the dry run. Now I would have used the set just because I just have to check for the existence of a subarray. So it might happen that okay, I'm having this prefix sum and I'm having this remainder. Now if I have got the same remainder in the past, and I will be just checking in the inside the set that okay, I have got the remainder, and I got to know that okay, this is the subarray. There will be a subarray which is having a sum which is multiple of 6. But because this particular problem is also having one constraint, that whatever the subarray should come as a result, that subarray must be of length at least, means the length can either be 2 or it can be greater than 2 of a particular subarray. So for that I will be using the unordered map. Let's just take this as the unordered map. Okay, and in this I can just name this unordered map by this name MPP. And now let's just start with taking the prefix sum. So this is the prefix sum I will be maintaining, prefix sum, and this is 0 as of now. Okay, so I have maintained this prefix sum 0 as of now, and I will be just starting from here, from this 0th index. Now I will be taking the prefix sum in it. Just 23 is added inside this prefix sum, and okay, so now we have got this particular prefix sum 23, and when we take the remainder of it, like 23 mod 6, so when this is perform the mod operation in it, the remainder will come as 5. 23 mod 6, it will give us the remainder 5, and we will check inside the map that okay, 5 is available or not. So 5 is not available inside the map, therefore 5 will be added inside this map. 5 along with its index, means at what index that remainder came. That remainder came at 0th index, so therefore that 5 will be inserted along with its index. Now this I moves ahead, and I moves ahead at this particular remainder will prefix sum will now become 25. And now again we take the modulus operation, or get the remainder. So 25 when divided by 6, it is going to give me the remainder 1. And 1 is now again checked inside the map, so we have not found any of the remainder like 1, so 1 will be added inside this map along with the index. So at 1 index we have found this remainder 1. So now I will move ahead and we'll see value 4. Now 4 is added inside this prefix sum, so it will now become 29. And when the mod operation is performed with 6, what will the remainder come? The remainder will now again come as 5. Okay, so the remainder is 5. Now we will check inside the map. So 5 was the remainder, and that was at 0th index. Okay, so we have checked from the map that okay, this 5 was the remainder encountered inside the map. See, and that was encountered at 0th index here. Means 23 was the prefix sum at that time, and when the remainder was taken, that was 5. So it means from 1 index till this 2 index is a particular subarray whose sum is multiple of 6. Means this particular subarray is having a sum 6 which is multiple of 6. Okay, so we got a one subarray. Now here itself we have to return true because we got a subarray. But we also have to check if this particular subarray is having the length 2 or not. Means length 2 or more. So now what we have to do, the moment we got this particular remainder, that we have okay, that we have seen this particular remainder in the past at some particular index, then we can get to know that okay, from that index plus 1 till this current index is a subarray whose sum is multiple of key. But along with this, once we have checked that okay, this is present inside the map, just put up one check hit there that okay, this is a subarray, but firstly check if its length is 2 or more. So we will just, how like in the previous problems as well, we have seen that how we have to get the length. This is the current index, so we will just write this current index I minus, and whatever the last index where we have got this remainder, that 0th index, how we will get that map of this key, that will give me the index of that I minus 0. So in this I is 2 and that is minus 0, it is giving me 2, so therefore it is 2 or more. Okay, so the length is 2, at least 2 I wanted, so therefore I will be just returning true in that case, that I want the first array or the first subarray which is having the sum which is the multiple of 6. So I can just return true in this case. Until the end, if I'm not getting any of the subarray, then I can just return false in that. So let's just directly get into the implementation and implement this as well. Okay, so this is the function which I have to complete, and okay, now in this firstly I will have to take the n in which I will be taking the nums of size. And after this, now we should check a case where if the k value is equal to 0. So it means we have to check for the subarray whose sum is a multiple of 0. And that can only happen in the case where the subarray sum is having itself the sum 0. So that for that we have to check. And also we have to keep one thing in mind explicitly, that okay, that subarray can have the sum 0, where the one index and only having, or the one length is only having a subarray sum 0. That can also happen, but we want the length as 2 or more, means at least 2 lengths should be there for that subarray. We will have to check for at least uh, like two zeros, means adjacent zeros. So for that I will just put a condition here, that if this k value is equal to 0, and in that case I will just run a loop in order to check for two adjacent zeros. So for int I equal to 1, checking from one index if it was present at 0 for the previous one, I less than n, and this I plus plus, I will be just putting a condition if this nums of I is equal to 0, and nums of I minus 1 is also equal to 0. It means I have found two adjacent zeros, and therefore their sum is multiple of 6. Okay, and therefore I can return true in this case. And after completing this entire loop, if I am not getting any of the such thing, then I can return false in that case, that I have not got any of the subarray sum is multiple of 0. So I have not got any of the subarray whose sum is 0, at least with length 2. So this is the edge case. Let me just write here, this is the edge case. Okay, and now after this I have to do the simple thing, like if the k value is any non-zero value, then I have to do the same thing which I will be doing. Like first of all, yeah, I have already taken this unordered map. So let me just the unordered map. Now the unordered map will be here. In this unordered map, this map, firstly I will have to insert for the 0 remainder and along with its index minus 1. Okay. And now I will be maintaining a prefix sum here. So the prefix sum initialized with 0 as of now. After this, I will be just running a loop for int I equal to 0, I less than n, I plus plus. Firstly I will be taking the prefix sum. So prefix sum equal to this nums of I, and once it is taken I will just get a remainder equal to prefix sum mod of k. It is going to give me the remainder. And once I get this remainder, again the same thing I have to do, I have to check for the remainder status. So if this remainder is less than 0, means if the remainder is negative, and in that case I have to just take this remainder, means already I am having the prefix sum mod of k. I have to just add k to it in order to get it into its valid range from 0 to k minus 1. And once it is done, I will just put a condition here. If this map dot find, I am finding this remainder inside this map, and if this remainder was found inside this map, this map dot end, and once this remainder is found inside the map, then okay, I know this is the remainder of this prefix sum at this current index, and I have found the same remainder in the past in the map. So therefore the difference of these two prefix sums will be giving me the subarray whose sum is multiple of k. Okay. And now if I got this, I just have to check for one other condition which is actually mentioned inside the problem, that okay, I have got the subarray, but that subarray should be of length at least 2. For that I will be just putting a condition how I can get the length of this subarray, that is I current index minus what is the index of that particular value, or that remainder inside the map, that is map of that remainder, and that is giving me the length. Just check if it is greater than or equal to 2. If it is the case, then just return true in that case, and after this also we have to do, okay, this is the if condition, like if we have got the remainder, so we are going to do things like first we are just getting the length, it is checking the length, it is greater than a 2 or not, at least 2 should be there. If it is the case, then we will return true. Else, what is the else case? Else case is that the remainder which we are checking inside the map, that was not found, and if it is not found, then we will have to add it inside the map. For the map with that remainder, just adding along with its x. Okay, so this is the else condition which we have put, and this is only because if the remainder we have found, then that's not the problem. We have found the remainder and we will be just checking for its length. If it is greater than 2 or not, we will just return it. Otherwise, the remainder is not found. Therefore, we will have to add it inside the map. We will just take that map along with that remainder and update or insert it with its corresponding index. This is what we have to do. And now at the end, we just have to return false if any of the subarray we did not get with the sum multiple with multiple of 6 and also having the length at least 2. Not got any of the subarray, then we can return false in that. So let's just take our example. 23, 2, 4, 6, 7. Size is 5, 23, 4, and for what value we have to check? The value 6. Let's just turn it. Okay, so there exists subarray of length at least 2 with some multiple of 6. Okay, so there exists means already we have seen that this particular subarray exists from 1 to 2 index. The subarray 1. There is also one subarray with which is having this sum 6, which is again divisible by 6, but because it is having the length of 1, so therefore it will not be considered. We just have to check for the length at least 2 and also some multiple of 6. We have got this subarray. Therefore, it is giving this output. There exists the subarray length at least 2 with some multiple of 6. Okay, so now let's just check the time complexity and space complexity. So in this we can see one loop is running in case like if the k value is 0. So in that case, it will be checking for the complete array, and this particular loop is going to perform the operations as an operation, so O of n. And if it is not the case, okay, so it is going to return here itself O of n. And if it is not the case, then again the same which we are doing in the previous problems as well. One loop is running for every value. This unordered map is going to take the constant operations for the insertion and for the search operation. The time complexity is going to be O of n. Okay. Now again, in the case of space complexity, the space complexity will be also O of n in the worst case scenario. Okay. This is all about this problem. Okay, so in this particular video, we have solved two problems, and whatever the code and all stuff will be there that I will be putting inside my GitHub repository. Its link you can find in the description. Uh, there are more problems as well, like based on the XOR approach, like XOR operations as well, and also some small tweaks, also some small variations are made. The similar problems which we have solved till now, so that maybe I can cover in the previous in the like upcoming videos, but maybe I can start with the newer pattern from the next video. Okay, so till then, just keep growing and keep learning along with me, and that's all for this video, and we'll meet in the next video. Thank you.